All right, let's dig into a pretty wild idea today. What if you could build software that's guaranteed to be high quality and, easy to maintain, right? From the very first line of code. We're going to explore this whole concept through the surprisingly complex world of a simple to-do app. I mean, you know the story, right? We've all been there. A project kicks off with this super clear, simple goal. But then, over time, new features get kind of bolted on, the technical debt starts piling up, and before you know it, what was once a really clean idea is just a complex, unmanageable mess.
But what if you could build a system that just prevents that chaos right from the start? Well, that is exactly what we're looking at today. A project that's built on this incredibly structured foundation, one that's designed for clarity, quality, and totally predictable growth.
Okay, so let's actually dive in here. At first glance, what you're seeing is a pretty straightforward command line to-do application. You can add tasks, list them, filter them, all the stuff you'd normally expect. It's clean, it's functional, and honestly, on the surface, it looks just like any other to-do app you've ever seen.
And this is the key. Beneath that simple interface, there is something way more profound going on. See, this isn't just a random collection of code. It's a whole system governed by a detailed and, frankly, powerful constitution that dictates every single move a developer makes.
So what is this code constitution we're talking about? Well, don't think of it like a simple style guide. Oh no, think of it more like the supreme law of the land for this project. The Constitution is this formal document, and it basically lays out the project's entire DNA. It defines the core values, the big architectural rules, even the specific technologies that are allowed. And here's the kicker. If a proposed change violates the Constitution, it gets rejected. End of story. It's as simple as that.
So at the very heart of this Constitution, you've got these 4 core values. The whole thing demands a process that's deterministic, predictable, and that always puts quality and the user first. But the real key, the thing that makes it all work, is this principle of spec-driven development. And that means nothing, no feature, gets built until it's been completely and thoroughly specified in writing first.
Okay, so that's the theory. But how does this actually work in practice? Let's walk through the exact process of adding a new feature, from the initial idea all the way to the final code.
It all starts with a pretty simple high-level request, just like this one. The goal here is to evolve the basic app to support better organization and usability. Add some priorities, tags, search, and sorting. Pretty standard stuff for a feature request, right?
Now, in a normal project, this might just get tossed over to a developer. But in the spec-driven world, oh no. This simple prompt goes through a really rigorous process that turns that kind of vague idea into a set of ironclad, non-negotiable rules.
And the very first step, you forget about code completely. You just focus 100% on the user. What do they actually need to do? That big, high-level goal gets broken down into these very specific, actionable user stories.
So suddenly, that vague idea of organization and usability becomes 3 really concrete goals. Users need to create more detailed tasks, they need to find those tasks easily, and they need to sort them. It's this level of clarity, right here, that becomes the foundation for absolutely everything that follows.
Okay, so once we completely understand the user's needs, then they get translated into the language of the system. We're talking about a list of explicit, testable, and totally non-negotiable functional requirements. This is the stage where ambiguity goes to die.
And just look at the level of detail here. It doesn't just say add tags. It says the system must allow adding up to 10 tags. It specifies color coding for priorities. And that last one, FR010, that one's fascinating. It's actually an architectural rule. It makes sure all the business logic, the brains of the whole operation, stays in one specific part of the code. And that is absolutely critical for long-term maintenance.
So, a big question is always, how do you know when the feature is actually done? Well, in this system, it's not when a developer just says it is. Nope. Success is defined right up front with clear, measurable outcomes that leave 0 room for debate.
Let me give you an example. It's not enough for the search feature to just, work. It has to return results in under 1 second, even when searching a list of 1,000 tasks. That's a hard performance metric that absolutely must be met. It's basically a promise of quality, written in stone before a single line of code even exists.
All right, so with the specification that's detailed in hand, what we really have is a perfect blueprint. So now we can finally move on to the actual development. And as you might expect, even this part of the process is incredibly structured and disciplined.
The workflow follows 4 very distinct steps. We just spent a lot of time on the all-important specify step. Next up, developers plan the technical approach, designing exactly how they're going to build the feature without breaking any of the Constitution's rules. Then, that big plan gets broken down into tiny individual tasks. Each one is just a small manageable chunk of work. And only then, at the very end of all of that, is code actually written to implement those tasks one by one.
And this entire system? It's all built on one golden rule that can never be broken. No code without tasks. That means every single change, every single line of code has to be directly traceable back to a specific task. And that task comes from a plan, which, as we know, comes from the specification. This is a secret weapon against scope creep and technical debt. It minimizes all that unplanned work and keeps the project on a clear, predictable path.
Now, I know what you might be thinking. This sounds like a lot of overhead, right? Especially for just a simple to-do app. But here's the thing. This discipline isn't about building for today. It's all about building for tomorrow.
Because by forcing every single idea through this rigorous spec process, you pretty much eliminate feature creep. It's gone. It ensures that every new feature is well thought out, that it adds real value for the user, and that it doesn't mess with the architectural integrity of the system. And the result? A high-quality, scalable product.
And you can really see how this enables a clear path forward. With the super solid foundation of Phase 1 complete, the project can now confidently move on to Phase 2, adding an API, a web interface, knowing that the core system is robust, well-documented, and totally ready to evolve.
So, when you put it all together, the contrast is, well, it's pretty stark. On one hand, you have the typical chaotic process that leads to feature creep and tech debt, but on the other, you get this deterministic process that delivers predictable features, maintainable code, and just consistent quality year after year.
And all of this brings us to the final question. Look, this level of crazy structure might not be for every project, but it raises a really powerful point, doesn't it? It forces us to ask ourselves, could injecting this kind of discipline, this constitutional approach, fundamentally change how we build, maintain, and grow the software in our own lives? It's definitely something to think about.